Greetings, I'm Professor Seth Frey, and we're going to discuss the scientific method, focusing on a specific part of it, the process of the part where you generate hypotheses and where you generate predictions to test hypotheses. So, we're going to start off with an overview of the scientific method. We're going to walk through an example of applying it in the social media, web science kind of context. And then we're going to drill in on the two parts that this course is going to focus on most specifically, hypothesis generation and sort of test generation. Okay, so scientific method, you start with a general question about the world. Then the hypothesis stage is where you generate possible answers, and they could be wrong. In fact, they're probably wrong. But there's lots of explanations for anything that happens in the world. So, question: why is my car acting up? Hypothesis: well, does it have gas? Is the battery charged? Is the engine broke? These are all explanations for why the car might be having trouble. So these are all hypotheses. And having generated several hypotheses, we can get into prediction stage. Prediction stage, we ask, okay, well, what could falsify or disprove or support any of those hypotheses, provide evidence for or against any of those hypotheses? Well, if I'm out of gas, then the gas meter is going to show empty. If there's engine trouble, maybe I'll smell something when I lift the hood. If the battery is dead, then well, I can think of bad ways to test that. Then no lights should be coming on. And my radio shouldn't turn on, and nothing electronic attached to the battery should be running. So those are all predictions, okay? The test is once you've generated the predictions, the test is often pretty straightforward. Sometimes there can actually be a lot of work. So for a lot of my personal stuff as a scientist, a lot of the work is between the prediction and test phase, or the test and analysis phase. But in the case of this car example, if the space between prediction and test is pretty short, you generated the prediction. Does it say E on the gas tank? And then you look at the gas meter, and maybe it says E or it doesn't. That's a pretty fast test. And then your analysis, it might be as easy as just looking at the dial. In that case, the data has already been analyzed. There was no putting in there was no complicated way of seeing how much gas was in the tank. So this example doesn't really have an analysis, but it might be that instead of getting where the gas meter was, you got a bunch of raw numbers, and you had to chug those in order to get some determination about how much liquid fuel is in the tank. So we can walk through that a little more concretely. With a web science example. It's not like the most brilliant example, but it's an example in the context of social media. And it's going to be, I just want to know, what are people like? What's social interaction like? How many friends do people tend to have? As humans. How many friends do humans tend to have? Now to really answer that, I could do a bunch of stuff. I could visit every person in every country and ask them, or visit every person in every country and follow them around for a couple of years and check boxes for every person. I could do that. Or I could just ask all the people in one country, more of a convenience sample. Or I could find some other even more convenient sample like the internet. Imagine checking out people's social media environments. But first, so that's the domain we'll be in. How many friends do people tend to have kind of online? So let's come up with some predictions. Well, one hypothesis I have is going to be kind of based on my experience in the world or on social media, which is that, I don't know, people kind of tend to have 100, 200, acquaintancy type people in their life. Some people have way less. Some people have a lot more. But all the people it's going to be somewhere in there. That's my prediction. And there will be people who are more, but they're not going to be dramatically more. There's going to be people with less, but they're not dramatically less. Okay, this is my guess. This is my hypothesis. average 100, two more, some less. And I might even say like the number who are beyond that upper limit is about the same as the number of people below that limit, and the extent to which they're above is related to the extent to which they're below. So it's like symmetric. So here's my prediction that we got a number of friends. That's the peak, is your average, is like, so, and that peak is going to be a number between 1 and 200. And there will be some people with more, some people with less, but it's going to fall off pretty quickly in either direction. So like that's kind of a specific prediction, and I've pinned it down now to Instagram. I'm looking specifically at Instagram or Facebook because I want this to be a testable prediction. I want it to be a prediction that could possibly have a wrong answer. So I want to be as specific as possible in my prediction. I'm going to go on Instagram. I'm going to track, this is our test. I'm going to go to Instagram. I'm going to visit lots of accounts. I'm going to count the followers of all those accounts. And I'm going to keep track of everything I found. And what I'm going to end up with is like a list. For every account I looked at, maybe I looked at 100 accounts. I'll imagine like I'll have 100 rows of data, and there'll be, and one column is going to be that account, another column is going to be the number of followers that person had. Why followers instead of people you follow? Well, maybe they're a more authentic measure of like acquaintances. Now, you might be thinking, wow, this is really far from like friends. Like people who follow me on Instagram are not necessarily my friends. And I have a lot of friends who are not following me on Instagram. So this sounds like a pretty bad measure. It's almost, I'm arguing, it's actually kind of intentional. The scientific method does not give direct access to like the truth. Every single study is giving just a little, every single study you'll ever read has serious problems. There's no like perfect methodology for learning things about society. Anything we really confidently know about society was not the result of one study. It was the result of dozens of studies on lots of populations from lots of directions. So you can imagine this study, this Instagram study, as like providing one little additional brick in like a wall of evidence that would be necessary to really answer our question about how many friends people tend to have. So we're providing that one kind of incremental small contribution by going to Instagram, visiting lots of accounts, and counting the followers. So with that big data set, all these rows, if I visit 100 people, I've got 100 rows of data. Then we can, and if I visit 1,000 accounts or 1,000,000 accounts, because I know how to automatically scrape Instagram in code, then we get into the analysis phase where we turn that big pile of numbers into some interpretable conclusion. And actually what we're going to find, this is interesting, that my hypothesis was wrong. I don't get anything that looks like a bell curve. I don't see that people tend to have 100, 200 friends, some less, some more. I see something a lot more like this curve. So a lot of people have a couple followers. There's a lot of people, and most people have 1 or 2 or 3 or 4 or 5 followers. And then the number of people who have 6 is less, and 7 is less, and 8 is less than that, and 9 is less than that, and on and on and on and on and on until you get into the 1,000. I think Instagram might have a max of 5,000. No, it's 5,000 people you can follow. Yeah, no. So you get into the millions in terms of. But so as number of friends goes up, there's a small number of people with a huge number of followers. We're gonna call that a fat tail, and because it's not like it declined really quickly. It did decline quickly, but not to zero. No matter how far out we go, there's still like some chance that we're gonna find someone with that crazy number of followers. So rather than seeing some symmetric kind of reasonable distribution like you'd expect for height, most men are, at least in this country, are 5'8". You have a couple who are 5 inches taller than that, a couple who are 5 inches shorter than that. The number of people who are 5 inches taller, 5 inches shorter are about the same. And your chances of finding a 7-foot person are really small. Your chances of finding a 9-foot person are nil. It's not going to happen. To see this kind of distribution in height, the friend distribution in height, that would be imagining that like almost everybody you meet in your entire life is 2 feet tall. But if you go around enough, you will find people who are 7 feet tall, 9 feet tall, 20 feet tall. That's what the world would be like if height distribution looked like the distribution of people's friends. So social relations are fundamentally different from this kind of bell curve relation that describes a lot of stuff in the real world. That's what our analysis would have found in this web science example. And if you pay attention as you browse around on Instagram, that's what you're going to tend to find. You're not exposed to a lot of the accounts with very few followers, but if you somehow can access randomly draw accounts from Instagram, the vast majority of them are going to have almost no followers, maybe 0 followers, and then there will be a small number with a crazy number of followers. So, okay, so having gone through all the steps of the scientific method, once in theory, another through an example, question, hypothesis, prediction, test, and analysis, we're going to drill in on the second and the third step. That's where this class is going to make you practice the most. So I'll be giving you some research questions, some high-level thing about society, and I'll ask you to generate explanations. Why could it possibly be that way? I'll give you something analogous to why is this number different here versus there? Why does this type of person have more or fewer friends than that type of person? Why does this place receive more tweets than that kind of place? So that'll be my overall question. Then you'll come up with explanations. Oh, maybe that one person's more popular. That one place is more popular. Maybe more people who go to that place tend to have Instagram or Facebook or Twitter or whatever. These will be the hypotheses you'll generate. And I'm going to ask you to generate several hypotheses. Maybe they'll compete, like only one of these answers could be true. If one's true, the other must be false. That's the really cool when that happens, that you can get hypotheses that compete, that science can really move forward a lot that way. But most of the time, especially with the kind of data we're looking at, the answer tends to be like the answer to the question. If my question is which of these hypotheses is right, the answer tends to be both. Science is a complex, society is a complex system. Everything affects everything. It's often the case that there's room for both of your hypotheses, for all of your competing explanations to be true at the same time. So that'll be the first step of your assignments, is just come up with reasons why the data might look like this. You don't even have to answer. You just have to come up with hypotheses for possible mechanisms, possible explanations that would answer this question. Once you've done that, that's your step one. Your step two is going to be to think, okay, well, Seth gave me this data originally, and we used it to answer to like learn something about society. But it's not complete data. It doesn't give me everything about every single person who's involved. It doesn't tell me all the details. And that's why I can't answer my hypotheses. That's why I don't know which hypothesis is right or how right each hypothesis is. So for the prediction part, I want you to think, okay, if I can get any additional data set to complement this data set, if I could get any additional data, or if there were some more information about the people posting, or more information about when it was posted or where it was posted, if I could add richness to this data or complement it with another data set and sort of match it up, what data would I want, or what data would I need to test each of the hypotheses I posed in the first step? The purpose of all this is to give you an overview of the scientific method and how it relates to the content of this course, because you'll be practicing aspects of the scientific method every week. Or every other week, generating hypotheses and predictions and getting a feel for the science of society through online data. Thank you very much.